All right, so today's video is about ion formation and ionic bonding.
It's a twofer.
Yep.
Yeah. So you might notice at the top of your paper that there is a little box that's got a couple of definitions on it. What we want you to do is take a second to go back and remind yourself about those two terms. You may need to go back to your other notes, so what we're going to ask you to do is pause the video and flip back your notes, so we'll just kind of wait a second while you do this. And I think that's probably good enough time.
Woo!
Hopefully you remember now.
Good job, guys. Nice handwriting, too.
Woo. Here we go.
All right, polyatomic ions. Let's jump right into this. We already know that ions are a charged atom. Poly means many. So now what we have is many atoms together acting as a single unit. So if you look at our definition there, it says it's a group of atoms. So you know you got at least 2 atoms. In the case of our example down below, you've actually got 5. You've got phosphorus and 4 oxygens sticking off of that.
Is that what the little number at the bottom means?
Yes, that's what I was going to get to. Very nice. Look at you, you go-getter. That was good.
I see stuff.
That little 4, we call that a subscript because it's below there. And what it means is there's 4 oxygens because that 4 is attached to just the oxygen.
So it doesn't go with the phosphorus?
Nope, does not go with the phosphorus.
Oh, so like in H2O, when that 2 is written down there, that means there's 2 hydrogens?
2 hydrogens, H2. And then the O is there, and they're all together. But in this case, we've got an ion, and you can tell it's an ion because this next part, it's got a charge. That -3 is the charge on there. So it says that PO4, it's a group of 5 atoms together, is acting as one single unit, a thing we call a polyatomic ion. And the charge on that whole ion is -3, which means it has 3 extra electrons.
Cool.
All right.
Easy enough.
So you're going to learn 2 different categories of ions. The first one is called an anion. Now, an anion is an atom that has gained 1 or more electrons. So it's become an ion, specifically an anion. There we go. All right, so anions have a negative charge because if you gain 1 or more electrons, which are negative, that makes your charge negative.
You're gaining little negative particles.
There's more negatives than positives.
Now normally it's nonmetals that become anions because if you look at your periodic table, nonmetals are on the right side of the periodic table. Therefore, Mr. Harkins is grabbing one in case you don't believe me. Okay.
Look at all of them hanging out.
They have almost full, but not quite full, valence shells.
That'd be full.
So remember we talked about atoms try to react in such ways or they behave in ways that try to make them more stable. In other words, have a full valence shell. So in order for these to have full valence shells, they have to add in electrons, okay? And that gives them a negative charge. So some examples, chlorine has 7 valence electrons. It's going to add 1 valence electron in order to become
1 to go over to argon. Argon-like. It's not actually argon, but it gets an outer shell like argon. Excuse me there.
Because remember, the ions
He's
are
still
trying
recovering.
to mimic those noble gases.
Yes.
So, and then oxygen needs to gain 2 valence electrons in order to get a full shell. Therefore, it will.
It's going to gain that outer shell and just become neon. So that's if you're looking these things,
like
oxygen,
neon.
It's going to become like neon. It's going to have an outer shell like neon.
Okay. Yay. All right, so then the next category Mr. Black will take.
Ooh, okay, so the opposite of negative, everybody, is?
Positive.
Positive,
I was
very
say
good.
That.
Yes, positive.
I was going to say that.
And a positive ion is one that has lost 1 or more electrons because now you have less negatives and more positives. Not because we gained more positive, but we just actually lost the negatives. Because remember, can we lose protons, everybody?
No. It'd be a new element.
Right, then we're something totally new.
Yeah.
So positive ions we call cations. So cation is what we get when you've lost your electrons and you've become positive. So they each get positive charges.
Easy way to
There's gotta be
remember
one.
that.
I know one.
You have a way to remember it?
What is it?
So here's the way to remember
cool.
this. Cations are positive.
Oh, I will never forget that now. That was really good.
So once again,
really good.
cations are positive.
I'm all on that.
Maybe you should write that little trick at the top of your notes to prove that you're paying attention.
And then everybody go like this. Positive.
Yeah, when I check your notes, go positive.
Something lamer than white of the sky? Positive cations.
Nice.
All right.
So typically we say that metals are the ones that are going to become cations because they tend to lose electrons easily. Metals, if you forgot, are on the left-hand side of that little funky little staircase thing.
Like that.
And they usually will lose electrons. Another way to kind of think of it, if you look at sodium Sodium is positive because of +1. It's in that first column. It has one little valence electron, so it's far easier to lose it than to try to gain 7 more. So it loses that one and become plus. Calcium, on the other hand, is in column number 2, the alkaline earth metals, and that becomes a +2 because it loses 2 electrons to become more stable. A general rule of thumb, if you have 3 or less valence electrons, you're going to lose them and become positive. If you have 5 or more, you're typically going to gain them and become negative. The ones with 4, they're a little weird. They'll do both, depending on what they do with. But don't worry about that.
All right, so we're going to practice the little section in the middle here about actually forming ions. So I'm going to take the first one, and we're going to figure out what kind of ion that chlorine will form. So first you got to look at the group number. Now if you look at chlorine, it is in group 17/7A. Okay? Now what that tells you, I always say either look at this number or look at this number to tell you the number of valence electrons. So we know there are 7 valence electrons. Now as far as metal or non-metal, it is on the right side of the table. That means it is a non-metal. Okay? Now, here's where you really have to think. You think to yourself, okay, this number 7 right here, is that closer to 8 or closer to 0? Because an atom is either going to try to add electrons to get up to 8 to get that full valence shell, or it's going to try to give away electrons so it goes down to 0 and therefore gets rid of that outer orbital and then has a full outer shell. This number is closer to 8 than to 0. So you got to think, okay, how many electrons does it need to add to do that? It only needs to add 1. So it's going to add 1 electron. Now remember, that electron's negative. So that means this atom is going to have a negative charge. Okay? So chlorine minus 1. You notice the charge is the opposite of number of electrons gained or lost. And as we know, cations are positive. This is not a positive ion, so it is an anion. Here you go, Mr. Harkins.
All right. So let's take a look at magnesium here. First thing I want you guys to see is magnesium. It's in group 2 or 2A. That should be a pretty easy one. If we look at that, then the number of valence electrons on that, if you count over there, it's got 2. Now it says, is it a metal or a non-metal? Well, it's way over on the right, almost, or on the left, almost as far on the left as you can go. So that would actually be a metal, which is very cool. Now if we take a look at this, it's got those 2 valence electrons. And if it's closer over on the left, on the metal side, we got to figure out, is it going to gain electrons or lose electrons? In this case, it's easier for it to lose those electrons. And magnesium would hopefully, if it loses 2 electrons, get an outer shell, an orbital that looks more like neon, element 10. So element 12, magnesium, wants to lose 2 electrons. So what that's going to do is if magnesium loses 2 electrons, it's actually going to have more protons in there. It's going to actually have a positive charge opposite of this little guy. So the positive charge is going to be +2. That is a terrible looking plus sign, but that is magnesium +2. And because it's positive, that means that it is going to be a cation. And this is my cation. Look at that. Cat. There you go. Does that make sense? If not, please ask us in class. Thanks.
All right, so now we're going to actually look at how ions are formed. And specifically, if you take an ionic compound, meaning a compound held together by ionic bonds, how you would figure out the formula for that. So, for example, this problem here is, hey, you have iron and you have oxygen, which is also known as rust.
Yeah. Ferric oxide.
So, yeah. Anyway, so how do you write rust here? Well, you have your iron atoms, you have your oxygen atoms, you figure out what kind of ions they will make. So iron, you'll notice has, and usually we'll give you this information, will become a cation of +3, and oxygen will become an anion of -2. So this technique here is called drop and swap. What you do, you take the different charges that are on those atoms and you kind of move them to the other atom, like this.
That
magical.
Yeah, ILM came in.
And you'll notice
$3,000 for that.
And you'll notice that if you take those numbers then, so there are 2 iron atoms and 3 oxygen atoms. If you do like your little balancing, you'll notice now you have +6 charge with the irons and -6 charge with the oxygens. and that'll make that a nice even compound.
Okay.
So there's 2 iron atoms and 3 oxygen atoms.
So the way to do this then is we take the charges of those ions and we switch them so that they become the subscript on the opposite ion.
Right.
So they crossed over, and then you get rid of the plus and the minus.
Correct.
And if it's all balanced and they've canceled each other out, the charges are balanced, because when you make a compound, they don't have a charge, right?
Right.
Because they're not reactive, they're kind of stable.
Yep.
So ions have the charges because they're real reactive. They're trying to grab or lose stuff, and those stuff is electrons.
Yep.
Got it. All right. That's cool. So there it becomes
Fe2O3.
Fe2O3. Okay, I get it.
Yep.
That's kind of easy. I think I can do that.
Too bad. So here's some practice examples. Now what we're going to do is we're going to go through a couple of them real quick here to kind of demonstrate this for you. So
Well, the answers are already there.
no, but I mean if you go to these are some. If we go to the next slide, we're going to see some practice ones. So here we
Gotcha.
have K plus 1 and F minus 1. If we drop the charges and crisscross, you just get KF because the negatives and positive disappear. 1 potassium, 1 fluorine.
Yep.
Nicely done. We go to the next one. Calcium is plus 2. Chlorine is minus 1.
I think I got this. I'll take the +2 and put it down on the bottom right of calcium. I take that minus sign, that -1, of chlorine.
Yep.
And then I take the -1 on chlorine and put it next to calcium, and I should have CaCl2.
You got it.
Yep.
Awesome.
So-
And
easy.
Notice we don't typically write the ones just
Yeah.
because it looks kind
Yeah.
of busy.
That's what I was about to say.
Oh,
Still
sorry.
my
I missed
idea.
it. I'm sorry.
A
My bad.
minus sign is just a -1.
All right, maybe one more here?
Yep.
And then, so number 3 here, we have magnesium, which makes a +2 cation, and nitrogen that makes a -3 anion. So let's take those numbers, drop them into the subscripts. We should have Mg3N2.
That's what I would
There you
say.
go.
There you go.
Now, one more we want to do real quick is because if you have a polyatomic ion, you got to do something a little bit different. So it's not really going to be seen here, but if you look, we're still going to crisscross our charges, and you end up with K2SO4. Sweet, nothing too bad there. But what happens when you actually need to move a subscript down on the outside of one of those polyatomic ions? Because I can't, like on number 5 here, magnesium +2, NO3 -1, I can't change that little 3. That 3 by the oxygen has to stay the way. Imagine that it's like its arm. You can't just take its arm and remove it. It has to stay there. So what you're going to do is you're still going to bring the 2 down for NO3 and the 1 down for Mg, but to make sure that 2 goes to all of the NO3, you put the NO3 inside of parentheses.
So what you're saying
Just
is
like in math
NO3
class.
is the polyatomic, right? So
Yep.
it's 1 nitrogen, 3 oxygens. And if I'm going to put that 2 down there and say I want 2 of all of that, I have to put it in a little bag, a little container.
Yes.
So I put parentheses around it and then put the 2 outside of that and say give me 2 NO3s. So I would have 2 nitrogens in there and 6 oxygens in there.
You got it.
I get it. That's pretty neat.
So
Okay.
how about this, real quick? Why don't you take a second, see if you guys can do 6, 7, and 8. So hit pause
Yeah.
again, see if you can get the
On
answers.
some scratch paper or something.
Yep.
We'll need
Off
a
on the
second
side.
for ya.
Take a second. Try these. It will be worth it. Trust us. And go.
Okay.
All right.
You sure we got it?
See
So
the
let's check your answers. Yes, I know you got that one.
Oh, way to go. Oh, wait, I bombed
Oh.
that one. No, that was hard.
Oh, but they got it, so they're good.
Yeah, so I had to put the parentheses around NH4, and I forgot to do that, and I made it NH42. That was way too many hydrogens. That's crazy. Okay.
What we got here? Okay. Ba with OH and a 2. Ooh, I almost got that one wrong because I tried to put the 2 next to the hydrogen only, which would have not been right.
That would have been a water. H2O. That would have been weird.
Okay.
All right. Well, that's it for today.
Yep. Hopefully you guys are masters at writing ionic compounds now, and we will see you in class.